Okay, so you guys wanted to see how to solve this triangle, which has, importantly, a 24-degree angle opposite a 16 side, a 36-degree angle opposite an unknown side, and an unknown angle opposite an unknown side. Careful, careful, this isn't a right triangle. You guys see that? Okay, so if I know that this thing isn't a right triangle, I know the Pythagorean theorem and the usual SOHCAHTOA stuff is forbidden to me, right? Because that stuff only works in right triangles. Okay, so I am left with only two options. So when I see this, I think to myself, okay, there's a law of cosine thing, right? Which works when you have, let's see, law of cosines has 3 sides and 1 angle in it, right? So at the very least, I need to know either 3 sides and then I can get an angle, or 2 sides and an angle and I can get the other angle, or the other side, rather. On this, I know only 2 angles and 1 side, so this thing isn't going to help me here. Not going to help. The other tool I have is this law of sines thing. Okay? You guys remember law of sines? You want to write it down?
Yes.
Yes? What is it? Go down.
Sine of A over little a equals sine of B over little b equals sine of C over little c.
Perfect. Okay, so this thing tells you about the sine of an angle divided by the opposite side. That ratio is the same throughout this triangle. Okay, so how do I make that useful to me here? Let's see, I need to target something to solve for, right? Okay, so what do I know? I have 24 degrees, right? And I have this 16 opposite that. That's one of these pairs, right? Okay, so that's a totally known pair. Sine of 24 degrees over 16. And then I want to look for one of these other pairs where I know something. You see that? So like right now, I know this angle 36, and that's
A?
unknown, right? But that's one of those pairs. You guys see that? So I can say, okay, this thing is sine of 36 degrees divided by whatever that side A is. Cool. Is the third one going to be useful right now?
No.
Why are you shaking your head? Why not?
Because multiplying 3 fractions is hard.
Yeah, good. Because you really want one equation to solve, right? You already have one equation here. Why complicate things? So how am I going to solve this?
Multiply 16.
Okay.
Both sides.
So we want to multiply both sides by 16. Sure. So I get sine of 24 degrees is 16 sine of 36 degrees over side A. Does that help? Kind of. All right, what do I want? I want A by itself, right? On the top. A is on the bottom, right? Okay, so I'm going to multiply both sides by A to get it back to the top. So I'll get A sine of 24 degrees is 16 sine of 36 degrees. With me on that? And then what? I want A by itself. Divide by what?
Sine of 24.
Nice. So we'll divide both sides by sine of 24 degrees. And we'll get A is 16 sine of 36 degrees divided by sine of 24 degrees. Cool. Okay, is this something I know right away? Like are those standard angles?
No.
Oh, crap. So I'm going to have to settle for an approximation. Okay, so I'm going to approximate by cramming this in a calculator. When do you guys do that? Be careful with your parentheses, Dan. Why am I telling her if you don't close this one,
Like parentheses, 16.
so
sine.
you want 16 times sine 36, and then make sure you're in degrees mode, right?
Yes.
And then close that parenthesis,
Okay.
and then hit divided by sine of 24. What do you get?
23.1219.
1, 2, so 23.12,
Yes.
all up there. Does that look about reasonable in our picture?
Yeah.
So one thing, I should probably check, is this angle about 24 degrees? I mean, it doesn't look too far off at least. Is that one about 36 degrees?
Yeah.
Probably. Is that side a little bit longer than that one?
Yeah.
Yeah, probably should be. The angle's a little more open, right?
Mm-hmm.
Okay, so I'm kind of okay with that 23. And so I think I punch that in, right? Where do I get this other jazz from? So like right now, I know this is 23.12 here, right?
Mm-hmm.
And now I need another pair, right? But I don't know either part of that pair.
Well, you kind of do, right? I mean,
Well,
it's
I-
120 because, like, the angle.
Good. So the sum of all three angles, right, has to be 180 degrees. So this one here has to be what's left, which is how much?
120.
120 degrees. You guys all see that? Okay, so if that's 120 degrees, now I want, what do I do?
Can you, like, use the same one and just substitute sine of 120 over c?
Perfect. So I still have this ratio, right?
Yeah.
So sine of 24 degrees divided by 16 is, and now on the other hand, right, I can cover up this one and just talk about the first and the last. So that should be sine of 120 degrees divided by
C.
c. Cool? Okay. So you want to do this, let's do this one a different way. What if sine of 24 and just calculate it quick?
.4067.
Okay, now hit divided by 16.
.025.
Okay, so 0.025 is approximately sine of 120 degrees divided by c. See that? And now I can multiply both sides by c. Right, so I'll get c is times 0.025, right, is approximately sine of 120 degrees. And so c is approximately, what am I going to do?
Divide.
Divide by
.025.
0.025. Perfect. So I'll get c is approximately sine of 120 degrees divided by 0.025 gives you something out of the calculator. $120 is actually a standard angle, right?
Is it?
Yeah. So 120 degrees is here, this is 60 left over. Okay? So the reference angle for that is 60 degrees. We could calculate the sine exactly on this. What do you get?
34.64.
Okay, so, oops, and on this I have a little bit of a whoopsie. I think C is 34.64, right? But really I should be saying this is approximately, right, because I rounded this. Cool. So if I was actually coming up with a list of things that I found, what would I actually find? Like, to summarize.
two sides, side C, side A, and then,
Okay, so I found side C is approximately 34.64. Side A is approximately 23.12. Why am I, some of my two small lines over
And angle C is 120.
and angle C is actually 120 degrees. Okay, see that? I got one hard equals because I actually know that, and the other two are approximations. Do they seem right?
Yeah.
Yes.
Maybe more or less. This one looks like it's probably about half again as long as that. And that seems to be what's happening with the numbers. That'll probably work. Cool, questions, thanks? So law of sines this way always works really conveniently. When you're sine inversing angles, right? When you know some of the sides and you're looking for the angles, law of sines can be a little bit tricky, especially right near 90 degrees, because there's two angles right there. It's hard to tell sometimes from the pictures. So be a little bit careful with this law of sines when you're looking for angles.